Okay, here we are, last day of chapter 7, and we are going to be solving rational equations in just a slightly different way than we did yesterday. So the big idea for what we're going to do today is, yesterday we did cross multiplication, right? So that looked like something like this, where you might have had x plus 2 on the top and x minus 3 on the bottom equals, and then you might have had something on the other side like x minus 5 over 6. Okay, we could cross multiply with those because we had one term on each side. So we had one fraction bar over here, and we had one fraction bar over here. When you have that situation, you can just cross multiply and solve. I just totally made that question up, so I'm not actually going to solve it, but you can cross multiply if the problems look like that. Today, we are going to look at problems where you cannot cross multiply. So a problem that might look like this, where you have 2 over x minus 5 plus 3 over x equals 10 over x squared minus 5x. Okay, if you notice, this is an example where you don't cross multiply because there are two terms on the left. So if you notice, okay, on the left there are two terms, which means in order to cross multiply, you actually can only have one term. So you're okay on the right side because you've got one term over here, but as long as there's a plus sign separating two separate terms like that, you can't just go ahead and cross multiply from the get-go, which means you have to have a different method, okay? And so what we are going to do is we are basically going to clear our fractions by finding a common denominator. So what that looks like with plain old just simple fractions, as much as we might hate fractions, I'm just going to do a true statement, okay? If I have 1/4 plus 3/4, okay, we can figure that out. 1/4, well, let's not do 3/4 because we don't want it to, plus 5/4. I just didn't want it to equal 1 whole, okay? Equals 6/4. Okay, if you notice how it works is as long as the denominators are all the same, the numerators make a true equation. As long as it has 4, 4, 4, everything in the denominator is the same, everything in the numerator makes a true statement. So if we have 4, 4, 4 means that 1 plus 5 equals 6. And it even works if you don't have like denominators. So let's do a nice easy example. I have 1/2 plus 3/4 equals 5/4. It's a true statement. Believe me on it. We'll show it in here in just a second. At the moment, you do not have like denominators across the bottom. You have a 2, you have a 4, and you have a 4. We need to rewrite that equation so that all of the denominators are the same. That way we can eliminate the fractions. To do that, I would need to rewrite 1/2 so that it has a denominator of 4. Well, that just means I'm going to multiply the top and the bottom by 2. So then I would have 2/4 plus 3/4 equals 5/4. And now we have denominators are all the same, which is going to mean our numerator is going to make a true equation. Denominator is the same. 2 plus 3, in fact, does equal 5. And it works the exact same way with rational expressions, or excuse me, not expressions, now we're doing equations. It works the exact same way with rational equations. If you find a common denominator, that's going to make the numerators one simple equation to solve. So let's, take a look here at how we do that. Okay, so we have x plus 6 over x minus 4 plus negative 30 over x squared minus 5x plus 4 equals 3 over x minus 1. When in doubt, what's the first thing we do? Factor it out. Okay, so when in doubt, we're going to factor. That's always going to be our first step. So I can factor x squared minus 5x plus 4. And if I factor that, I get x minus 4 and x minus 1. Okay, so now I'm done with that because I factored it out. We are not trying to cross reduce, we're not cross multiplying, we're not doing anything. We need to figure out how we can make the denominators all the same. Well, if you notice, the middle term here has an x minus 4 and an x minus 1, which means everything needs to have an x minus 4 and an x minus 1. Well, this guy over here has an x minus 4. What it's missing is x minus 1. So, just like we did before, I'm going to multiply the top and the bottom by x minus 1 of just, let's see, of just this one. Okay. Then in my middle term, or in my middle part here, I've already got x minus 4 and x minus 1, so I don't have to do anything. And then on the right, I have x minus 1, but I'm missing x minus 4, so I just need to multiply the top and the bottom by x minus 4. So now everything in the denominator has an x minus 1 and an x minus 4. So let's go ahead and finish out each term. So here on the far left, I've got x minus 1 times x plus 6. When I FOIL that out, I get x squared plus 6x minus 1x is plus 5x, and then negative 1 times 6 is plus 6. And I have x minus 1 and x minus 4 in the denominator. Plus, then in my middle term here, I have negative 30 on top, and I have x minus 4 and x minus 1 in the bottom. On the other side, I need to distribute, so I'd have 3x minus 12 over x minus 1, x minus 4. And just like we did with those simple fractions, all of this is the same, which means we can solve the numerator. Oops, daisies, I didn't mean to do that. I wanted to highlight. We can solve the numerator as one equation. So I can say on the left I have x squared plus 5x plus 6 minus 30. Oops, that should be minus 6 right there. I apologize. This right here, this right here should be minus 6, not plus 6. I put the wrong number there. That should be a minus 6. Let's fix that. So I would have, coming back down here, when I have x squared plus 5x, and then I have negative 6 and negative 30 is minus 36, equals 3x minus 12. So what I had highlighted in green is now just, and then since my denominators are all the same, all I have to do is solve my numerators. So I would have x squared, and then, oops, daisies. So we have a quadratic here. I kind of got ahead of myself there, which means I need to get everything set equal to 0. So I'm going to subtract 3x from both sides. I'm going to add 12 to both sides. And I get x squared plus 2x minus 24 equals 0. And just like any other time that we do, I'm going to come over here, I need to factor that out, which would leave me with x plus 6 and x minus 4, because that multiplies together to be negative 24, adds together to be positive 2, equals 0. And then I would get either x equals negative 6 or x equals 4. However, let's not forget, I didn't stress this yesterday when we were doing cross products, but let's not forget we do have variables in the denominator, and remember the rule, you cannot have a denominator of 0, which means if I put either 6 back into my original equation or 4 back into my original equation, it cannot make the denominator 0. So as I'm looking, negative 6 is fine. That does not make the denominator 0 anywhere. However, if I put 4 back into the denominator here, 4 minus 4 is 0, which we can't have. So that would be an extraneous solution, and we would only have one answer. Okay? So we're going to I have a few more examples. We're just going to keep practicing with this idea. Okay, so I have 2 over x minus 5 plus 3 over x equals 10 over x squared minus 5x. First things first, factor. So I'm going to factor an x out of that, and I would be left with x minus 5. And now I look at my denominators. I have x minus 5, x, and x times x minus 5. So I know I need to have an x and an x minus 5 in every one of them. So I know I need to multiply the top and the bottom here by x. This one I need to multiply the top and the bottom by x minus 5. And this one over here on the right is all good because it has an x and an x minus 5 already. So when I put things together, I have 2x over x times x minus 5 plus 3x minus 15 over x times x minus 5 equals 10 over x times x minus 5. Again, once these denominators are the same, they have cleared themselves out, which means I can just say that my numerators are equal to each other. So if I combine my like terms, I would get 5x minus 15, because I get 2x and 3x is 5x, equals 10. Now I'm just solving for x. I'm going to add 15 to both sides. I get 5x equals 25, x equals 5. So when I go back, always go back and check. I have x equals 5. Well, if I put 5 back into my equation, my original equation right here, I get 5 minus 5, which is 0, which means that's an extraneous solution. And that means, well, if the only solution I got didn't work, that must mean that there is no solution for this problem. So we can have answers that look like that also. Oops, there we go. Okay, last couple of problems here. These will probably go a little bit faster. Okay, so I have 2 terms on the left and 1 on the right, which means I need to solve by finding common denominators here. And when in doubt, as we say, factor it out. So I'm going to rewrite this one as x minus 5, oops, x plus 2. So I don't need that anymore. And if you notice, I have an x minus 5 and an x plus 2 over here. This one has an x minus 5, this one has an x plus 2. So my first term over here, I'm missing an x plus 2, so I need to multiply the top and the bottom by x plus 2. Over here, I'm missing the second one, I'm missing an x minus 5, so I need to multiply the top and the bottom by x minus 5. And on the right, I'm good because I have both of them in the denominator already. So my first term, I'm going to have x squared plus 2x over x plus 2x minus 5 plus, and then I distribute here, I get 2x minus 10 over x plus 2x minus 5 equals 11 over x plus 2x minus 5. Okay, so now I have my denominators are all the same, which means I can use my numerators to solve the equation. So I would have x squared plus 2x is 4x minus 10 equals 11. It's quadratic, so I need to get it set equal to 0, so I need to subtract 11 from both sides. I get x squared plus 4x minus 21 equals 0. If I factor, I get x plus 7 and minus 3, which means my 2 solutions are either x equals negative 7 or x equals 3. And if I go back and check, if I put negative 7 in the denominator, not a problem. And if I put 3 into the denominator, it's not a problem either, because it makes none of those denominators 0. Okay, last problem as an example here. I have x plus 6 on the bottom, x on the bottom, and x plus 6 on the bottom. which means that, let's see here, I have x plus 6, x plus 6. So I need to have an x and an x plus 6 in the bottom of every one of them. Well, this first term, in this first term, I'm missing x, so I need to multiply the top and the bottom by x. Second one, I'm missing an x plus 6, so I need to multiply the top and the bottom by x plus 6. And this one over here, I'm missing an x, so I need to multiply the top and the bottom by x. Which leaves me with x squared plus 1x, because I distributed here, plus, over x times x plus 6, plus 1 times x is x, 1 times 6 is 6, over x times x plus 6, equals, if I distribute that x in there, I get 2x squared plus x over x times x plus 6. Now all of my denominators are the same, which means I can solve my numerator. So I have x squared plus, I got x plus x is 2x plus 6 equals 2x squared plus x. Okay, when I look at this, I have a quadratic. I want to get it set equal to 0. I want my coefficient of x squared to be positive, so I'm going to go ahead and subtract x squared. And I'm going to subtract my 2x from both sides, and I'm going to subtract 6 from both sides. That leaves me with 0 over here. Then I have x squared minus x minus 6. Again, I'm just going to factor. Well, I'd have x minus 3 and x plus 2. Multiply together to be negative 6, add together to be negative 1, which means my solutions are either 3 or negative 2. And if I go back up to the top up here, if it's 3, not a problem. And if it's negative 2, not a problem. The only ones that would have been a problem is if it was 0 or negative 6, because that would have made the denominator 0. So you will have a homework assignment over this. It will be in Schoology, so you need to actually go through, and it's going to be 4 questions just like this. It's just going to be different ones, but very similar in the idea. So good luck.